All right, so just right underneath that, yeah, I have 3 practice problems real quick. Calculating sound, we have 2 equations that we're going to use, both of which are velocity equations. What are our 2 velocity equations? Distance over time and frequency times wavelength. Time, frequency times wavelength. Go ahead and also fill out your triangles. No, just on this. Copy them down and we'll transfer them tomorrow. Now in our triangles, our velocity, our first velocity, what's going to go on top? Distance is going to go on top. That's right. And then our velocity and time are on the bottom. And our bottom equation, our frequency and lambda, which is going to go on top? Velocity is going to go on top. Frequency and lambda are going to go on the bottom. Your choice. Okay, so you're going to do rectangle power, of course, for each of these. So here's our first problem. It says a wave takes 3.5 seconds to travel 5,187 meters. Just sketch one out. It doesn't have to be pretty. How fast did the wave travel is the first question. And then a follow-up is what medium is it traveling through?
What's your medium?
What substance? So, of course, I'm going to identify my variables. 3.5 seconds is a time. 5,187 meters is a distance. So I'm going to put those in my givens. What am I looking for? Velocity. So, what equation am I going to use?
V equals distance divided by time.
V equals distance divided by time, that's right. Of course, I don't have my triangle up there, but feel free to put yours. I'm going to plug in my numbers, showing my work, and then I'll plug it in my calculator. Taylor, I dare you to get out a calculator and do this.
Do you have money?
Do you have a calculator?
Yeah.
I think we're at 7 here.
Question? I have the answer. Does everyone have an answer?
Yeah,
Okay,
it's
answer.
kind of like scientific notation.
Sure. Put in scientific notation. 3 sig figs. So does everyone get this as an answer?
Yeah.
1.48 times 10 to the third meters per second. Ma, you have a question?
No.
Do you have an answer to something? Now, Maya, what are you going to do next?
Find the medium.
How are you going to do that?
You just go numbers first.
You're gonna look on your chart for velocities. So you're gonna look up 1,480. What do you find?
Water.
You find that it is water, right?
Wait, how do you know?
Hey, did you look up your velocity chart?
Or what?
Your velocities that we wrote down yesterday? And just compare. 1,480 meters per second is water, right? Good. All right, let's try this one. Distance. It says a sound wave in air takes 2 seconds to reach you. How far away are you from the source? So 2 seconds is a 2 seconds is a time.
Yeah.
And that's all we're given, right? What are we looking for?
Distance.
Okay, the distance. So what else should we know? Velocity. So how do we know velocity for air? It says it's in air. So we look up in our chart for velocities, and we find that in air, our velocity is 343 meters per second. While looking for our distance. So we manipulate our equation. What do we find? D equals V times T.
Sorry.
And then we plug in our numbers. Plug in chug. Multiply how fast it goes for how long it travels.
Oh, no.
And we get
6.86 B to the 2. B to the 2.
686 meters.
Oh.
Or 6.86 times a second if you want. Questions on that one? Simple?
Yeah.
Question, how long does it take a sound wave to travel through 5 miles of steel? Now, we're given, what are we given in problem? A distance. And we know velocity. Can we use 5 miles?
Now
We have to convert it to meters. How many meters in a mile?
1,700. I don't know. 5,000. No.
1,600? In our notes,
That's not right.
1 mile equals 1,600 meters, right?
Oh.
Remember?
Oh.
Okay, so down below here, I'm going to do a conversion. So I have 5 miles over 1. We're converting to meters. A mile is bigger, obviously.
8,000.
You get 8,000 meters. Now you can plug that into your equation, right? We have 8,000 meters, divide it by how fast it's traveling. And that gets us our answer. Which is
1.34.
1.34 seconds. Questions on that? Simple, right? Remember all of these equations?
Yeah.
Our equation triangle from our wave unit, which by the way we'll be going over that test tomorrow. I'll get this back to you. You should all be familiar. So if I give you the frequency and the velocity, you should be able to find the wavelength. If I give you the wavelength and the velocity, you should be able to find frequency. If I give you the wavelength and frequency, you should be able to find velocity.
We didn't do a frequency problem.
That's because we did in last unit. They're the same. Except the biggest problem with these, or the biggest biggest complication is people trying to use speed of light. You do not use speed of light with any of these. You have to use the right velocity, and that depends on what it's traveling through.